Let's start with new chapter. Today we are starting with aldehydes and ketones. Today we are going to start with aldehydes and ketones. Yeah, we have completed the alcohol phenols. Yeah, now we are starting with aldehyde and ketone. Now again, in this chapter, I'll not directly completely focus on IUPAC. IUPAC we have already done in the detail. Yeah, and soon I'll be sharing one tricks video on the IUPAC. One reel we are trying to make where you will remember the order of functional group. Yeah. Okay. Chalo. Let us start with aldehyde ketone. And by the way, raise hand who have given weekly test this time. Raise hand option who have given weekly test this Sunday. Only Kevin. Sarjana, what happened? Yes, Prashanti, did you give it? The weekly test? Yes, Sarjana, what happened? This time it was CBSE based. Your exam, CBSE exams are coming soon. It was for you. Do not skip the test. Yeah, tests are for you. I do not even shout at you if you get less marks. But if you do not attend the test only, then how it will work? Do not skip test, attend the test. So, aldehyde, ketones and carboxylic acid. Now come on, quickly tell me what is the functional group of aldehydes? Yes? Correct, Sarjana. Yes, Kevin. What is the functional group of aldehyde? Prashanti, Gopinath. What is the functional group of aldehydes? Don't know? Aldehydes, what is the functional group? Prashanti? It is C double bond O. No. C double bond O and O. No. Okay, it is CHO. C double bond O. You have to add an extra H. Prashanti. Aldehyde means what? You have R. C double bond O H. If you have H, it is aldehyde. If you have C double bond O R, it is what? R C O R. It is ketone. Okay, it is ketone. So remember, this is aldehyde. This ketone. What is carboxylic acid? Sarjana, Kevin, Prashanti. What are carboxylic acids? Don't tell me what are carboxylic acids. Carboxylic acid functional group. COOH. Correct. So I will have R C double bond O OH. Correct, Prashanti. R C double bond O OH. So over here we are now not only going to focus on aldehyde, ketones and carboxylic acid, but also derivatives of it. Derivatives of it means what? Those are derived from your carbonyl compounds like acyl halide, or we call it as acid halide. If I replace the OH with Cl, R C double bond O Cl, we call it as acid halide. Because this is your carboxylic acid, I have replaced the OH with Cl, so I'll call it as acid halide. Acid halide. Yeah. Then I can have amides. Amide means if I replace, suppose this R by NH2. R C double bond O NH2. This is nothing but amide. This is nothing but amide. Correct? Then what is an ester? Prashanti, Sarjana, Kevin. What is an ester? What is an ester? Very good, Kevin. Yes, Sarjana, Prashanti, what is an ester? What is an ester? Ester is nothing but if I replace this H with OR. R C double bond O O R. C double bond O O C. You can call it as R. R C double bond O O R. Okay, C does not sound correct. Okay, R C double bond O O R. This is ester. Okay, this is ester. Then you have anhydride. Anhydride. Anyone remember the anhydride? Yes, Kevin, Prashanti, Sarjana. Anyone remembers anhydride? Yeah. Anhydride. Anhydride. I have given it a pet name if you remember. Anhydride. What is anhydride? Yeah, Kevin. What is anhydride? I had given some pet name to anhydride. Isn't it? Anhydride, the pet name I had given Sarjana is bullet. Yeah, anhydride looks like bullet, Kevin. That means what? CH3, C double bond O, O, C double bond O, CH3. This is called as acid anhydride. What do we call it? Acid anhydride. Isn't it look like bullet? Yeah. Or does it look like a mouse? Or does it look like a car from the top whose tire has come out? What what can you imagine? How does it look like? Yes, Arjuna? How does it look like if you look it from the top? Acid anhydride. Yes, Kevin, what can you imagine? All three. Okay, acid anhydride. Acid anhydride. Okay, so in the book it is written as CH3CO twice. Oh, CH3CO twice. So that is a acid anhydride. That is a acid anhydride. Come on, write it down. These are all your functional group we are going to study in this chapter. But the name of the chapter is what? The name of the chapter is aldehyde, ketones and carboxylic acid. But all this we are going to study. Actually, the name should have been carbonyl compounds. Okay, the name should have been carbonyl compounds. Because these are all the carbonyl compounds and that is what we are going to study in this chapter. Okay, carbonyl compounds. Come on, finish it and tell me done in the chat box. Finish it and tell me done in the chat box. Okay, okay, let us go ahead now. Let us start with now. Let us start with the nomenclature. No, let us start with directly your aldehyde preparations. Let us directly start with the preparation of aldehyde. Nomenclature we will do it along with the your reaction. Give the heading Sarjana, Kevin, preparation of aldehyde. Give the heading preparation of aldehyde. Okay, let us prepare some of the aldehydes. Let us prepare some of the aldehydes. Come on, give the heading preparation of aldehyde. Preparation of aldehydes. Okay, so the first preparation what we have is the reduction. Now, what is reduction? Kevin, Sarjana, what is reduction? Yes, what is reduction? What do we mean by reduction, Kevin, Sarjana? Gain of electron. Apart from that, for organic chemistry, what is reduction? For the organic chemistry, what do we mean by reduction, Sarjana? Or what do we mean by oxidation? Remember that reduction, if you want, write it down on the top, Kevin. Oxidation means addition of oxygen or removal of hydrogen. Right on the top, correct, Sarjana? Oxidation means addition of oxygen. Write it in your book, Kevin, Sarjana. Oxidation means what? Prashanti, write it in your book. Oxidation means addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen. Okay. For organic chemistry, oxidation means addition of oxygen or removal of hydrogen. And for reduction, write it down opposite. Sarjana, Kevin. For reduction, write it down opposite. Reduction means what? Addition of hydrogen and removal of oxygen. Addition of hydrogen or removal removal. Okay. Addition of hydrogen or removal of oxygen is your reduction. Okay. So the first is from acyl chloride, or we call it as acid chloride. Acyl chloride or acid chloride. Now you have written it just now. Tell me what is acid chloride. Kevin, Sarjana, you have just written it now. Acid chloride. What is acid chloride? Yes, what do we mean by acid chloride? RCOX. Perfect. So suppose I have acid chloride in the form of R is my benzene ring. Okay, R is my benzene ring and C double bond O Cl. C double bond O Cl. Now, if I do the reduction in the presence of palladium, okay, if I do the reduction, or we call it as what? We call it as a hydrogenation. Okay, so what happens in reduction? We add the hydrogen. So if you add the hydrogen over here, so one H gets added, one Cl goes out. So this is called as what? What you have got over here, you have prepared aldehyde. You have prepared aldehyde. So from acid chloride, you have prepared a aldehyde. What is the name of this aldehyde, by the way? Come on, tell me the IUPAC name of the aldehyde. Benzaldehyde. Perfect. This is benzaldehyde. So whenever you have palladium BaSO4 act as a poison. Whenever you have a palladium BaSO4, please remember this. Sarjana, Kevin, Prashanti. This is called as, write it in the bold. This has come so many times. They have asked the name of the reaction. Rosenmund reaction. Rosenmund reaction. Chat box. Write down the reactions and done in the chat box. Come on. Write down the reaction. This is your Rosenmund reaction. This is your Rosenmund reaction. Rosenmund reaction. Rosenmund reaction. Come on, Kevin, write it down. Done. Done. Okay. Let's go to the next. Very important. The next is a Stephen reaction that we prepared from nitrile. Come on, tell me what is a nitrile. Kevin, Sarjana, Prashanti, Raghu, Gopinath. What is a nitrile? Very good, Sarjana. From nitrile. Nitrile means what, Kevin? Yes, what do we mean by nitrile, Kevin? Nitrile is C triple bond N. Perfect, Prashanti. Nitrile is what? C triple bond N. So I can have CH3 C triple bond N. Okay. So RCN. This is what? What will be the name of this? 1 carbon, 2 carbon. This is your ethane nitrile. This is your ethane nitrile. Ethane nitrile. Okay, so if you have CH3 C triple bond N, okay, and if I react it with, now over here again triple bond, I have, what I am doing? Reduction. Sarjana, Kevin, what do you mean by reduction? Reduction means addition of hydrogen. So if I add hydrogen across the triple bond over here, what I'm going to get? I do it in the presence of teen. What I'll get? I'll get CH3 CHNH. CH3 CHNH. So C double bond N. This is called as imine. What do we call it? We call it as imine. We call it as imine. And when we do the hydrolysis of this, hydrolysis is very nice thing over here. Very funny hydrolysis happen. Look over here. This breaks down over here. O this time, H to this side. So what we have got? CH3, CHO plus ammonia. This is what we call it as ethanol. So this reaction, Prashanti, Kevin, Sarjana, we call it as a Stephen reaction. This is your, again the name is important. We call it as what, Kevin? We call it as Stephen reaction. Remember we have SN. So if there is SN, it is Stephen. It is Stephen. Mark it important. Come on, write it down. Write it down and done in the chat box. Write it down. This is your Stephen reaction. This is your Stephen reaction. Write it down, 7. Stephen. So remember SN for teen, SN for Stephen. SN for teen, SN for Stephen. SN for teen, SN for Stephen. I hope it is clear. Sarjana, Kevin. SN for teen, SN for Stephen. SN for Stephen. Done? Alright, sure. Let us go ahead. Instead of SN, okay, we can use a different metal also. Instead of SN, we can use a different metal called as dibel. What we can use it? We can use dibel. What is dibel? We can use dibel H. That is diisobutyl aluminum hydride. Dibel H. We can use dibel H. So again, Kevin, Sarjana, if I have a nitrile, okay, if I have a nitrile, Kevin, instead of your teen, I can use dibel. That is AlH. Okay, now in the exam, they can give you dibel like this, diisobutyl. That's why I bu twice. Okay, diisobutyl aluminum hydride. Diisobutyl aluminum hydride. That converts it to the imine, and again, if you do the hydrolysis, you will get aldehyde. You will get aldehyde. Okay, you will get aldehyde. So you have dibel. So dibel H means what? Diisobutyl. Write it down if you want. Diisobutyl, that is over here. Okay, diisobutyl. Al stands for aluminium. H stands for hydride. H stands for hydride. So dialuminium isobutyl aluminum. Diisobutyl aluminum hydride. Diisobutyl aluminum hydride does the same thing as a Stephen. Does the same thing as a Stephen. Okay, so does the same thing as a Stephen. Okay, and this is your dibel is selective towards CN. Okay, dibel is only selective towards CN. Does not touch double bond. Okay, does not. If you want, write it down. Does not touch. Does not touch C double bond C. Does not touch C double bond C. C double bond C remains unaffected. C double bond C remains unaffected. Okay, because generally what happens, Sarjana, Kevin, if you have a reducing agent, you add hydrogen across the double bond also, isn't it? But dibel is something which is selective only towards CN. You know the reason, Sarjana, Kevin, why it must be like that? See, what is a double bond? Double bond is nothing but negative. We can say because there are 4 electrons over here. Yeah, double bond is negative. And dibel H no gives you hydride. Hydride means H negative. Can negative attack on negative? No, it cannot. But in the C triple bond N, we have a triple bond over here. If I attack, it can move. That's why it attacks on the C. Are you getting it, Sarjana? Okay. Okay, so dibel H. Diable H, it also reduces ester. It also reduces ester. So whatever after oxygen you have will convert into aldehyde. So suppose I have a ester CH3, CH2, C double bond O, CH3. So whatever after oxygen you have will go away. Will go away and you'll get a again the same thing. Diable H, H2O. What I'll get? I'll get a aldehyde. Come on, write this down. CH3, CH2, C double bond O, H. And you have just prepared aldehyde. Come on, write it down. You have just prepared aldehydes. Just prepare aldehyde. Come on, write it down. Write it down and then in the chat box. Done. Okay, sure. Let us go ahead. Okay. This was a diable H. Now we are going to the important part. Sure. Now give the heading from hydrocarbons. Give the heading from hydrocarbons. Now what we are doing, Prashanti, Sarjana, Kevin, don't forget that what we are doing, we are preparing aldehyde. Yeah. So over here we have prepared aldehyde. Over here we have prepared aldehyde. Again aldehyde. Now next we are preparing aldehyde from hydrocarbons. Okay. From hydrocarbons. Now let us start with a very important reaction. So I have Sarjana. Suppose give the heading ozonolysis. Ozonolysis. Kevin, where do we find ozone? Yes, Bhubaneswari. Where do we find ozone? Sarjana, Prashanti. Ozone. Where do we find ozone? Atmosphere, is it? Yeah, where do we find ozone? Above the Earth's surface. Okay. So basically ozone is there in the stratosphere. Layer. But what is the role of ozone, by the way? What is the role of ozone? Sarjana, Kevin, Prashanti. What does ozone do? It is not in atmosphere first of all. It is in the stratosphere. Yes, Kevin, what do ozone do? What kind of? Yes, Sarjana. What will ozone do? Protect us from the UV rays. Prashanti, but how? Does ozone contain a gun? Oh, Prashanti is going to get Prashanti is going to get UV rays. I'll kill it with the gun. Yeah? Does ozone contain gun? It filters those UV rays. Yeah? It stops those harmful UV rays to coming down to Earth. Yeah? Then what is the molecular formula of ozone, by the way? Very good, Sarjana. Yes, Kevin, Prashanti. What is the molecular formula of ozone? Yeah? What is the molecular formula of ozone? O3. Okay, fine. So now I'll tell you a very important reaction. Okay, I'll tell you the mechanism and then I'll tell you the trick how to do it. Okay, now it is not there in the textbook, but it can come in their exam. Okay, so suppose I have in the ozonolysis, I have CH3, CH2, double bond, let us do CH3, CH, double bond, CH3. Okay, now if I react it with ozone, Sarjana, Kevin, if I react it with ozone, the first thing you are going to form is a ozonoid. What are you going to form? You are going to form a ozonoid. Okay, now we have used butene, so over here it would be butene ozonoid. It will be butene ozonoid. Now how do you get ozonoid? Kevin, Sarjana, it looks like a house. It looks like a home. Like this. This double bond is going to break away. CH3, CHO, CHO, O, CH2. This is your butene ozonoid. This is your butene ozonoid. And when you do the reduction of this, Sarjana, Kevin, in the presence of Zn and water, what happens? Look over here, Kevin, Sarjana. This bond breaks. Okay, this bond breaks. Look over here. Look carefully. This bond breaks. This bond breaks. What will happen over here? This moves, yeah, and this is going to go away with Zn. So what I'll get? I'll get ZnO, and I will have CH3, Sarjana, CH3, C double bond O, CH3, C double bond O H plus CH3, C double bond O H. Are you getting it, Kevin, Sarjana? What I have done? Okay, this both are one and the same. This is your acetaldehyde or ethanol. Acetaldehyde or ethanol. Come on, write it down. I'll tell you trick of this after this. Come on, write it and mark it important. Mark it important. Mark it important. Done? Kevin? Sarjana, is it done? Okay, now I'll tell you the trick how to do it. I'll tell you the trick. Suppose I have CH3, CH, CH3. Okay. Now in the exam, the question comes like this: CH3, CH, double bond CH, CH3. Okay. And the question will come: do the ozonolysis, then do the reduction. Then do the reduction. This is how the questions comes in the competitive exam. So what you'll do, Sarjana, Kevin, you'll just break this, add over here, add over here. Done. It is done. CH3, CHO, CH3, CH2. And this is what you have got it. CH3, CH2. Is it clear, Sarjana, Kevin? Yeah. Should I give you one example to solve? Will you tell me the IUPAC of that? Come on, write down this trick first. Come on, write down this trick first. Kevin, do not twist the tabs. Okay. Now come on, do this. Do this. Suppose I have CH3, CH2, CH, double bond CH2. And I do this reaction, ozonolysis, and ZnH2. Now you are going to tell me name of both the products. You are going to tell me IUPAC name of both the products, not the reactant. IUPAC name of both the products. Both the products. IUPAC name of both the product. Come on. Tell me the IUPAC name. Very good, Sarjana. Come on, Kevin, tell me the name, the IUPAC name. Prashanti, tell me the IUPAC name. Come on, try. It is very easy. Sarjana, I am giving you one more. You do that. Suppose I have CH3, CH, double bond C, CH3, CH3. Come on. Come on, tell me the IUPAC. Very good, Prashanti. For the first one, come on, do the second one. Sarjana, Kevin, do the second one. We are preparing aldehydes and ketones. Correct, Sarjana. Very good. I hope it is clear now, Sarjana. Yeah? Kevin, you have not given me answer of anything. Come on. What's wrong? I have not understood. Tell me. I'll explain it once again. What are you struggling with? IUPAC nomenclature? What are you struggling with? Prashanti, try the second one. So over here, Kevin, oxygen, oxygen. So what I have got? CH3, CH2, CHO, and CH2O means what? I have H, C double bond O, H, CH2O. So one is propanol, one is methanol. Similarly, Kevin, do the second. Come on, at least do the second. At least do the second. Prashanti, it is wrong. Come on, do the second one, Kevin. Sarjana, you do this till then. What about the second product? I want the second product, Kevin. I want the second product. I want to do this, Sarjana. Prashanti, your answer is wrong. Do it again for the second product. Do it again for the second product. One is correct, second is incorrect. Prashanti. Yes, Kevin, what will happen in the second product? Over here this breaks. Simple, no? Oh. One is acetaldehyde or ethanol, that is CH3CHO. And second is what? Prashanti. What is this? CH3, C, CH3, double bond O. What is this? Prashanti, is it propanol? I don't think so. What is this? Yes, Kevin, what is the second product? Prashanti, what is second product called as? Come on. Dimethyl ether, no. It is what? You have just drawn it, no Kevin? R, C, double bond O, R. Isn't it? What is this? I've just written it like that. R, C, double bond O, R. What is it? It is a ketone. It is your acetone. It is your acetone. Are you getting it, Kevin? Come on, write it down. That is your acetone. Correct, Sarjana? And what about the second product, Sarjana? Yeah. What about the second product? Sarjana, you are getting confused. I've just written it differently. It is one and the same. C to which you have attached 2CH3. Okay, my point is the same, Kevin. Just because I have written something like in a different way, that does not mean it changes the compound. Are you getting it? Over here, it is C, to which I have 1 CH3, 2 CH3. Same thing I have done over here. 1 C, to that I have 2 CH3. So why are you getting confused just because I have written it differently? Yeah? So if I eat food like this is the perfect example that our elders give us to. Yeah? If I eat food like this, it is same, and if I eat food like this, it is still the same. It is going to go in my mouth. Yeah, same thing. Are you getting it, Kevin? Prasanti, is it clear? You all are, you all are bobbleheads. Have you seen that bobbleheads in front of on top of the car? Yeah, the when you move the car, that bobblehead cartoons, they also move like this. Isn't it, Kevin? Yeah, Prashanti, isn't it? Have you seen it? Sarjana, bobblehead. See, acting like one. That was a trick question. Okay, so it is 2-methyl propane 1R and acetone. Correct. So let us go ahead. So this was your ozonolysis. I know Prashanti, Kevin, everyone, it is clear. No doubt in this. Okay, so from hydrocarbon we have prepared what? We have prepared aldehydes and ketones. Now next we are going to do is the oxidation by oxidation of methyl benzene by oxidation of methyl benzene by oxidation of methyl benzene, the oxidation of methyl benzene. Okay, methyl benzene, or what do we call this? Yes, Sarjana, Kevin, what do we call this? What is this? Correct. This is your toluene. This is your toluene. So if I have, now write down important, this is your Itard reaction. This is your Itard reaction. Two times it is coming in the exam continuously, Itard reaction. Okay, so what happens over here, that I will use something called as chromyl chloride. I use something called as chromyl chloride. Chromyl chloride is CrO2 chromyl Cl2 chloride. This is your chromyl chloride. This is a chromyl chloride. So in the chromyl chloride, what happens? You get a complex of chromium. That means what? Two hydrogens are replaced. Two hydrogens are replaced by your CrO2Cl2. That means it gets replaced like this. Look over here. Two hydrogens are basically added to the complex. Look over here, Kevin. So what happens? This is my benzene. Everything same. Now I will have CH and I will have chromyl chloride complex. So O, CrO, HCl twice. This is your chromium complex. This is your chromium complex. Chromium complex. Last year this complex was asked. Okay, last year this complex was asked. What is the complex that you get it in the Itard reaction? Last year this complex was asked. Okay, and if I hydrolyze this, in the presence of acid, what will happen? This will break and you will have O over here. So you will get a aldehyde, that is benzaldehyde. Come on, write it down. Mark it important. This is, give the name, Itard reaction. This is your Itard reaction. This is your Itard reaction. This is your Itard reaction. Come on, write it down and done in the chat box. Archana is done. Kevin, done. Prashant is also done. Bhuvanesh is also done. Now second is again a similar reaction, but this time you do not use chromyl chloride, you use chromic oxide. This was your chromyl chloride, now you will use chromic oxide. Okay, chromic oxide. Now what is chromic oxide? You do not have chlorine. Instead of Cl2 you have another oxygen. You have another oxygen, that is CrO2, CrO3, chromic oxide. CrO3, that is chromic oxide. So what I'll do, I'll have a CH3, correct, CrO3, correct, and I will have acetic anhydride. Now you tell me all what is acetic anhydride. Sarjana, Kevin, I do not want my trick as the answer, I want the compound as the answer. What is acetic anhydride? What is acetic anhydride? What is acetic anhydride? Yes, Prashanti, acetic anhydride, what is it? You forgot something, Sarjana? Oh. Okay, so acetic anhydride, Kevin, it is your bullet. CH3, C double bond O, O, C double bond O, CH3. In the book, it might be written as CH3, CO twice O. Okay, this is the acetic anhydride. Same thing, exact same thing. Okay, so what happens this time? You do not get a chromium complex, but you get a complex of anhydride. You get a complex of anhydride. So what happens over here? You have again two hydrogens will be replaced and you will have CH. Now instead of your chromium, I have OCOCH3 twice. I have OCOCH3 again if I do the hydrolysis, yes, if I do the acid hydrolysis, what I'll get? Again I'll get a benzyl derivative. Again benzyl derivative. Again I'll get a benzyl derivative. Come on, write it down and done in the chat box. This is what we have done using chromic oxide. Come on, write it down. Done. Kevin done. Rachana done. Prasanti, on finish it. Done. Okay, so this was your chromic oxide. Let us do one more reaction, then I'll give you two. Okay. Now next is your side chain hydrolysis. Side chain chlorination and hydrolysis. Side chain hydrolysis. Okay, same reaction. Okay, if you see, one thing is common in all the three reactions that we have done. Okay, one thing is we are taking toluene. Okay, this is how you have to study also. Okay, one thing is we are taking toluene. Okay, now if I do the reaction over here, chlorination, so what will happen? Again the same thing. In the last reaction, Sarjana, what happened? Two hydrogen got replaced, we got a complex. Over here, two hydrogen got replaced, we got a complex. Same thing over here, two hydrogen will get replaced and the chlorine will get added. Two hydrogen gets replaced and chlorine will get added. And now again the same thing I'll do. I'll heat it, acid hydrolysis. What I'll get? I'll get an aldehyde. CH. Are you getting it, Kevin, Sarjana? Come on, write it down. So this is how you have to study. You have to compare and study. You can see all three are doing the same thing in the first step. And that first step, intermediate, can be asked in the exam. The intermediate can be asked in the exam. Is it clear, Sarjana, Kevin? Come on, write it down and done. And by the way, what is the meaning of H mu? In a chemical reaction, when do we use H mu? Yeah. When do we use H mu in any chemical reaction? Yes. What is the meaning of H mu in a chemical reaction? Kevin? What is H mu? Prashanti? Sarjana? H mu in a chemical reaction. H mu means it is a radical mechanism. Okay, you are irradiating a light on it. H mu means what? Light. Okay, it is a radical mechanism. Okay, like for example, if I have Cl2 and if I am irradiating light, it will give you a radical like Cl radical, Cl radical. And this is how these reactions work. So remember, whenever you have H mu, this can come as one of the MCQ. H mu, whenever you have, it is a radical mechanism. It is radical mechanism. Okay. So let's take a break. What is the time? 8:02. I want to sharp over here by 8:11. Okay. We have already started late, so do not waste time. Please come back by 8:10 so that we can begin at 8:11. Okay. Come on everyone, back in the chat box. Everyone come back. Come on back. Sure. Let us begin. I hope it is clear till over here. Sarjana, Kevin. Okay. Now give the heading and write down very important Gatterman Koch reaction. What we are doing, Kevin? What we are doing, Sarjana? We are still preparing aldehyde. Now next preparation is using Gatterman Koch reaction. Now this Gatterman Koch reaction. Gatterman Koch reaction. Gatterman Koch reaction. So Gatterman Koch reaction, very easy, very simple. I'll tell you how does it work. But now remember Gatterman Koch. What happens? I have a benzene. Okay. I will have a carbon monoxide. I will have a HCl, and I will have anhydrous AlCl3. Where do we use famous reaction for anhydrous AlCl3? Yes, Kevin, Sarjana. Where do we use anhydrous AlCl3? The famous reaction, Prashanti. Which reaction? What is the name of that reaction? Very famous. Yeah. Very famous reaction where we use anhydrous AlCl3. Forgot. What is it? No? Your Friedel-Crafts reaction, isn't it? Friedel-Crafts reaction is where we use anhydrous AlCl3. What is the role of anhydrous AlCl3? Sarjana, Kevin? Yeah? What is the role of AlCl3? What does AlCl3 do? What does AlCl3 do? What is the role? AlCl3, what is the role of AlCl3? Yeah? What does AlCl3 do? No? Yeah, what does AlCl3 do? AlCl3, remember, it is the Lewis acid. AlCl3 is a Lewis acid. What is Lewis acid, Kevin? Sarjana, what is Lewis acid? Yeah? What is the Lewis acid? What do we mean by Lewis acid? Come on, tell me. What do we mean by Lewis acid? Yeah? Lewis acid. What is the Lewis acid? What is the Lewis acid? Alright? Do not know Lewis acid? What is happening? What is the Lewis acid? To produce electrophile accepts electron. Lewis acid is something that takes the electron. Lewis acid is something that takes the electron. Sarjana, remember. Electron pair acceptor, correct. So how does it reaction work? We have COHCl. So how does this reaction work? C and O, Kevin. If I ask for the structure, how many bonds are there between C and O? Yes. How many bonds are there between C and O? How many bonds are present between C and O? Yeah. How many bonds are there? Double bond, is it? But C does not make double bond, no? Is it a double bond? Is it a double bond between C and O in carbon monoxide? Kevin? See, look over here, Sarjana, Kevin, the structure is like this. C triple bond O. Okay, C triple bond O. Oxygen has used lone pair, so oxygen is positive. C has an extra lone pair, that's why C is negative and it is stable. Are you getting it? So over here, Sarjana, Kevin, what will happen? You have HCl. Where will the H plus add? Come on, tell me. Where will the H plus add? Where will the H plus add? Where will the H plus add in this? Where will the H plus add over here? Alright, come on, you all are not answering at all today. What happened? Where will the H plus add over here? You have in front of you, no? You have C negative. What is happening? Kevin, you have C negative, no? So what will happen? H plus will get added over here. H plus will be added over here. Okay. So if H plus gets added, yeah, if H plus gets added, it becomes what? C, okay, double bond O, H. Now since negative is used, this is over here, you have HC, one more bond is left, that's what we add Cl for it, okay, that's what we add Cl for it. Or you can think like this, look over here, you have added the H, this is still positive, correct? So Cl minus attacks over here and it gets back its electron. So what we have got? We have got, Kevin, back, we have got H, C double bond O, Cl. And now the role of AlCl3 comes into the picture. So AlCl3, Sarjana, what it does? AlCl3 removes the complete Cl minus with the electron. It becomes AlCl4 minus. And what you have is a H, C double bond O with a positive charge because electron is gone. And now the benzene attacks on this and you get a product. Are you getting it, Kevin, Sarjana? So we had carbon monoxide, on that H got added because there is a negative charge. So you have got a C triple bond O plus, positive charge is still there. That's why Cl minus attacked on the carbon, electrons moved towards oxygen. Yes, and finally your AlCl3 remove the whole Cl minus, you have become AlCl4 minus, and this is positive, and now your benzene can attack. Is it clear, Kevin, Sarjana? Is it clear, Prashanti? Is it clear, Sarjana, Kevin, Prashanti? Come on, tell me. Okay, come on, write it down and done in the chat box. Write it down and done in the chat box. Sarjana is done, Prashanti done, Kevin done. Okay, let us write, this was your, we have prepared aldehyde. Okay, we have prepared aldehyde from your hydrocarbons. I hope it is clear, the preparation of aldehyde. It is not difficult. See, organic chemistry, I repeat, it is not at all difficult. It is very, 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 very easy. If we focus a bit, it is very easy. Okay, so please focus and practice. If you practice enough, you will get it. If you do not practice, you will not get it. Simple as that. Organic chemistry, Kevin, Sarjana, this time 50% of weightage is possible for organic chemistry. Imagine how many questions are there in the chemistry for NEET. Sarjana, Kevin, total questions. Yeah, I hope you know the paper pattern. Yes. How many questions are there in the NEET chemistry, Kevin, Sarjana? Come on, tell me. No? 45 or 50?
45 only, sir.
Yes, Kevin?
45 only, sir.
Not 50.
No,
Are you
sir.
sure?
Biology 90
Hmm.
and physics chemistry 45, sir.
You have 50 questions, Kevin. 5 are optional this time. Okay, what you are telling me
Oh,
is last to last year pattern.
yes,
5
sir.
optional you have, 50 questions you have. Out of that, you have to attempt 45. Okay.
Yes, sir.
Now imagine, Sarjana, Prashanti, Kevin, out of 50, if you have 25% of organic, imagine, and this is possible. They have not revealed it yet, but I am telling you this is possible, Kevin. Do not take organic chemistry lightly. 50% weightage is not a joke. Getting it, Sarjana? Yeah?
Yes, sir.
Hmm. Chalo. So revise. Hmm. Let us go ahead. Okay. Now next, let us prepare some ketone. Let us prepare some ketone. Okay, let us prepare some ketone. Let us prepare some ketone. Okay. Now we are preparing ketone. We are preparing ketone. Prashanti, Sarjana. Let us prepare ketone. Preparation of ketone. Preparation of ketone. Okay. Preparation of ketone. Now first we are again the same thing. What we are going to do? We are going to prepare from acyl chloride. From acyl chloride. Prashanti, Sarjana, Kevin, Bhuvanashri. Come on, tell me acyl chloride. What is the functional group? Yes. What is the functional group for acyl chloride? Yeah. Functional group for acyl chloride. Tell me. Yes, Sarjana. Functional group for acyl chloride. COCl. Correct. So again, I will have CH3COCl. Okay, CH3COCl. CH3COCl. Simple. It is so simple. I will have a alkyl cadmium. So basically I want a nucleophile. I want a nucleophile. That's why I will attach it to a metal. Okay. So what will happen? That R minus will attack on the carbonyl. Chlorine will go away. So what I'll get, Sarjana, I will have a ketone. CH3. This is nothing but a ketone. Now how do I get a alkyl cadmium on this? So suppose I started with RMgX. What is RMgX? Prashanti, Kevin, RMgX. What is RMgX? Yeah. What is RMgX? Grignard reagent. Yes, a Grignard reagent. So I have a Grignard reagent and I'll treat it with cadmium chloride. I'll treat it with cadmium chloride. So again, this is negative, positive. Attack on the cadmium, Cl goes away. Attacks on the cadmium and Cl goes away. So what I'll get? I'll get a alkyl cadmium. Plus, if I will have MgXCl. MgXCl. Are you getting it, Kevin, Prashanti? Okay. So that is how you get a alkyl cadmium. Then alkyl cadmium, you use it on acyl chloride to get a ketone. So this is your step 1. This is your step 2. Come on, write it down. Write it down. Yeah, write it down. Come on. Done. Okay. That is how you have got a ketone. You have got a ketone. Okay. Now suppose in the exam the question comes like this. Okay. In the exam the question comes like this. Suppose, what should I give you? Okay. Let us say I have C2H5 MgBr, C2H5 MgBr, okay, C2H5 MgBr, I have CdCl2, okay, and I have, let us say, what should I give you? CH3 COCl. Come on, tell me the final product. Final product and IUPAC. Final product and the IUPAC of the final product. Come on. Kevin, Prashanti, Arjuna, try this. Come on, try this. Tell me the IUPAC of the final product. It is similar like last reaction. You can refer if you want. It is similar like last reaction. You can refer the last reaction if you want. And tell me the IUPAC of the final product. Tell me the IUPAC of the final product. Okay. Yes, Arjuna, come on, try. No, Prashanti, it is wrong. Try again. Maybe you are struggling with the IUPAC. Write down the product. Write down the product. Maybe your IUPAC is wrong. It is correct, but your IUPAC is wrong, Prashanti. I knew it, your answer would be correct, but your IUPAC is wrong. Yes, Kevin, you are not answering. Come on, tell me what will happen over here. So I have, what did I tell you, Kevin? You have cadmium chloride. You have RMgX, isn't it? You have RMgX. So if you have a cadmium chloride, C2H5 MgBr, okay. The role of a Grignard reagent is to prepare a nucleophile carbon negative, Prashanti. So what will happen? I have cadmium chloride, that negative attacks on the cadmium, chlorine leaves, and I will have C2H5 twice cadmium. C2H5 twice cadmium. Then I'll treat it with what? I'll treat it with acyl chloride. So if I have a acyl chloride, that is CH3COCl, yes, this is negative, that will attack over here. Your Cl will go away, and what I'll get? I'll get a CH3 C double bond O C2H5, that is nothing but CH2CH3. So Prashanti, how it can be an aldehyde? This is what? RCOR. This is a ketone. This is a ketone, not an aldehyde. So 1, 2, 3, 4. So this is butane 2-one. This is butane 2-one because it is a ketone. Is it clear? Kevin, Sarjana, Prashanti, come on, write it down and done in the chat box. Come on, write it down and done in the chat box. Kevin, write it down. Is it clear? Sure. Let us go ahead now. Give the next heading. Give the next heading from nitrile. Give the next heading from the nitrile. Prashanti, Sarjana, come on, tell me. What is nitrile? What is nitrile? Very good. Yes, Prashanti, what is nitrile? Kevin, what is nitrile? C triple bond N. Perfect. C triple bond N. Okay, now again I am going to use a Grignard reagent. Again, I am going to give a Grignard reagent. Now, how do Grignard reagent work with nitrile? Look over here. Now, this reaction is similar to that of a Stephen reaction. This reaction is similar to that of a Stephen reaction. Suppose I have a nitrile, let us say CH3, CH2, C triple bond N. What are we doing? We are preparing a ketone. We are preparing a ketone. So if I use a Grignard reagent, come on, give me any Grignard reagent, Prashanti. I'll take your Grignard reagent. Give me any Grignard reagent. We'll use Prashanti's Grignard reagent today. Come on, tell me. Prashanti, CH3 MgBr. Okay. So suppose I have taken Prashanti CH3 MgBr. Okay, which is given to us by Prashanti. So this is positive, this is negative. Same reaction will happen. We have seen on nitrile in the Stephen reaction. This attacks over here. This comes up. So what I'll get it over here, Sarjana, CH3, CH2, C, CH3, double bond N. Now since electrons are moved on the nitrogen, what I'll get? N negative, and MgBr we already have positive. So MgBr. And we have already seen if we have imine, that is C double bond N, how does hydrolysis takes place, Sarjana? This bond breaks over here. OH. Simple. So what I'll get it? I'll get CH3, CH2, C double bond O, CH3. Come on, Prashanti, Kevin, Sarjana, tell me IUPAC name of this. What would be the IUPAC for this? Quickly in the chat box, what would be IUPAC for this? We have already seen this functional group R, C double bond O, R. What would be IUPAC for this? Prashanti, I expect a correct answer now. Perfect, Sarjana, it is butane 2-one. It is butane 2-one. I hope it is clear, Sarjana, Prashanti. Okay, so what we have done, we have prepared a ketone. And how? Again, we have used a Grignard reagent. We have seen how does a Grignard reagent work. And Grignard reagent which we have used, which is given to us by Prashanti. I hope it is clear. Yeah? Come on, give me yes or no in the chat box. Is it clear? Okay, come on, write it down and just give me a minute. Come on, let us continue. Okay, I hope it is clear. Prashanti, Sarjana, come back. Kevin, I hope it is clear. Rakul, Bhuvneshri, I hope it is clear. Yeah, can we go ahead? So we have done what? We have prepared again a ketone from a nitrile. We have prepared a ketone from a nitrile. Now let us go to again an important reaction. Now again we want to prepare what? We want to prepare a ketone. Now we are going to prepare ketone from benzene. Again, what are we going to use? Now this time we are going to use Friedel-Crafts reaction. Again, Friedel-Crafts alkylation. Sarjana, what do we use in the Friedel-Crafts? Kevin, Friedel-Crafts, what do we use? What reagent do we use in the Friedel-Crafts? Yeah? What reagent? Correct, Prashanti. Very good. AlCl3. Sarjana, what is the role of AlCl3? It acts as a what? You have written it in the bold in your book. What does AlCl3 do? Yeah? What does AlCl3 do? Yeah? Lewis acid. Lewis acid. Okay. Now what I'll do again, I have a benzene. Okay, let us say I have a benzene. Okay, and I have taken a benzene, and I can take anything. Acyl chloride, CH3COCl. I can take instead of CH3, I can add a benzene over here. Instead of that, I can add any alkyl group. I can add any alkyl group. So AlCl3, Prashanti, Sarjana, what it will do over here? AlCl3, what it will do? Yes. AlCl3, what it will do over here? Yes, it is a Lewis acid. It will accept electron, but it will become what? By accepting electron, does it only accept electron or does it extract one of the ion or one of the element also? What it does? Yeah. AlCl4 minus. Correct. So what will happen, Prashanti? It will take away the Cl minus. Whole Cl minus will be taken away. What I'll get? AlCl4 minus. And you will have CH3 C double bond O positive. CH3 C double bond O positive. Finally, benzene attacks on that. And what you will get? You will get a ArCOCH3, which is a ketone. And the name of this structure is acetophenone. Write it down. This is a acetophenone. Okay, so what we have done, Friedel-Crafts alkylation. We have added a Friedel-Crafts acylation. We have added a acyl group. We have added a acyl group. We have added a acyl group. Come on. Write it down and done in the chat box. Write it down and done in the chat box. Done. Sarjana done. Kevin done. Prashanti, come on, write it down. Done. Okay. Now next reaction, we have already done it in the part of reactions of your alcohol. Now again I'll tell you, and you have to write down that list, okay, which I am going to give you. Okay. So what happens is we are preparing aldehyde. Now aldehyde we can prepare it from alcohols also, Prashanti. Alcohol, what is the functional group? Prashanti, Sarjana, alcohol, yes, OH group. So if I have an alcohol, okay, so from alcohol. So how do I prepare it from alcohol? If I oxidize the alcohol, yes, Prashanti, what I'll get? If I oxidize the alcohol, I'll get aldehyde or ketone. I'll get aldehyde or ketone depending what type of alcohol I have, correct? And if I further oxidize that, I'll get a carboxylic acid. I'll get a carboxylic acid. So to oxidize, Prashanti, alcohol to aldehyde, I want to stop at aldehyde or ketone. So what I have to use? I have to use a mild oxidizing agent. I have to use a mild oxidizing agent, Sarjana. So if I have to go directly from alcohol to carboxylic acid, I have to use a strong oxidizing agent. I have to use a strong oxidizing agent. So what I want to do, I want to go from alcohol to aldehyde. I want to go from alcohol to aldehyde. We also called it as controlled oxidation. This is also called as controlled oxidation. Controlled oxidation. So what I am going to do now, Kevin, I am going to give you a list. Okay, I am going to give you a of list of reagents or oxidizing agents that are mild oxidizing agents. I am going to give you a list of mild oxidizing agent. What do I want? I want you to take out time now and write it down, because afterwards you do not write it down and it will be left as it is. Okay, so mild oxidizing agent means what, Prashanti? It will convert your alcohol to aldehyde or ketone. It will convert your alcohol to aldehyde or ketone. Okay, so let me share that list. Just a minute. So list is as follows. We have 12 reagents, 12 mild oxidizing agents. Now one more thing, Prashanti, Sarjana, when do we get a ketone? I have written aldehyde or ketone. Now when do we get aldehyde? When do we get ketone? Aldehyde we get when we have a primary alcohol. Look over here, Prashanti. CH3, CH2, CH2OH. This is my primary alcohol. So if I mildly oxidize it or I do the controlled oxidation, what will happen? The CH2OH, whole CH2OH, be careful with the number of carbons. Okay, your whole CH2OH will convert into CH2. Okay, this is your what? This is your propane R. This is your propane R. Yeah. So what I have got? I have got aldehyde from primary alcohol. And if I use Prashanti secondary alcohol, Sarjana, secondary alcohol like CH3, CHOH. Okay, CH3. So mild oxidizing agent, removing hydrogen, what I'll get? I'll get a keto. I'll get a keto group. That is CH3, C double bond O, CH3. This is a ketone group. That is your acetone. Come on, write it down. Write it down. When you use a primary alcohol, you get an aldehyde. When you use a secondary alcohol, you get a ketone. Done. Prashanti is done. Sarjana done. Okay, chalo now. Come on, write down the list. This I have given you from reference book. Mild oxidizing agents. Take your time. Take 10 minutes. I don't care. Take your time. Write it properly. I hope it is visible, Prashanti. all the possible mild oxidizing agents from the reference book. This will convert your alcohol to aldehyde or ketone. Primary alcohol, aldehyde, secondary alcohol, ketone. Secondary alcohol, ketone. Secondary alcohol, ketone. Write it down and tell me done when it is done. Archana is done. Kevin, I hope you are writing it. Come on, write it. Prashanti is also done. Kevin is also done. So let us do one more last reaction, an important one. Okay, then we will stop. Okay, let's do one important reaction, then we will stop. Okay, look over here. Now we are still, there's one more reaction by which we can prepare aldehyde of ketone. Okay, so similar to that of Markovnikov rule. Do you remember Markovnikov rule? Sarjana, Kevin, Prashanti, Markovnikov rule. Yeah. So when you have a when you have a double bond, okay, let us start with double bond. Okay, or a triple bond. Chalo, from alkyne. If I have an alkyne, okay, next is from alkyne. Suppose I have it from I have an alkyne. Alkyne means what? I have a triple bond, Prashanti. CH3, C, triple bond, CH. Okay, this is alkyne. Okay, now if I do the hydration, hydration means what? Hydration means I am going to react it with water. Okay, I am going to react it with water, and generally we do it in the presence of your mercury sulfate, HgSO4. This is your simple reagent. Okay, mercury sulfate and the acid. So what happens over here, Prashanti, Sarjana, your water gets added. Now water gets added as a Markovnikov rule. That means what? I have H plus and OH minus. Now tell me, Prashanti, where will the OH minus go? A, B, C. Yes? Where will the OH minus go? Kevin, Sarjana, where will the OH minus go? A, B, C. Yeah? A, B, C. Where will the OH minus go? Prashanti says C. Kevin, Sarjana. What was Markovnikov rule? You forgot. Negative part attaches to the carbon having less number of hydrogen, isn't it? Now you all will answer, I know. What? But you forgot the rule. Negative part attaches to carbon having less number of hydrogen, isn't it? So I will have CH3, C, double bond, OH, CH. Okay, now this is your enol form, little bit unstable. Okay, we stabilize it by making it a keto, enol keto tautomerism. Okay, so this double bond comes over here, H goes over there. Okay, this is CH2. Correct? Double bond comes over here, H goes over there. So what I'll get? CH3, double bond O, CH. This is a keto. This is a keto. So acetyl. I hope it is clear. Come on, write it down. Write it down and done in the chat box. Done. Okay, so we have completed with the preparations.